Alright, hi guys, this is a review video of Unit 1. It's a review for your test on Thursday on square roots and cube roots and finding the square roots of numbers that are not perfect squares. So let's go ahead and get started. Okay, you should have this set of notes in front of you which says Unit 1 review video. And we're going to go ahead and we're going to list the first 10 perfect squares. You need to know these for the test on Thursday. So the first perfect square as well as the first perfect cube is 1. And then if we do 2 times 2, our next perfect cube is, or square is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is not 88. 8 times 8 is 64, 9 times 9 is 81, and 10 times 10 is 100. So these are the list of the first 10 perfect squares that you need to know. Remember, we said a number was a perfect square. If you think back to the Cheez-It activity, can we make a square with that number of cheeses or that number of square tiles? Okay, next is the first 6 perfect cubes. Remember, a cube is just a number times a number times a number, where a square is just twice, a cube is 3 times. So if we do 1 times 1 times 1, we get 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. 5 times 5 times 5 is 125, and we just need the first 6, so 6 times 6 times 6 is 216. So those are the first 6 perfect cubes that you need to know. So on to finding the square root and the cube root of each number. The square root is of 49, so we have to think of what number can we multiply by itself twice that will give us 49. And we know that the square root of 49 is 7 and negative 7, because 7 times 7 equals 49 and negative 7 times negative 7 equals positive 49. So with cube roots, doesn't work quite that way. Cube roots, we only have one square root and it's either positive or it's negative, not both. So when we're doing the cube root, I want to know what 3 numbers can I multiply together to get 64. And that would be 4, because 4 times 4 times 4 equals 64. So that means that the cube root of 64 is 4. We also talked about what would happen if we didn't have a perfect square. So if we look at 24 and 50 and then go back up to our list of perfect squares, 24 and 50 are not on our list of perfect squares, so we have to estimate the square. So the square root of 24 is somewhere in between here. It's smaller than 25 and bigger than 16. So that tells us that the square root of 24 is between the square root of 16 and the square root of 25. And we know the square root of 16 is 4, because 4 times 4 is 16, and the square root of 25 is 5, because 5 times 5 is 16. So that means that the square root of 24 is somewhere between the integers 4 and 5, because 4 squared is 16 and 5 squared is 25. So let's take a look at the square root of 50. The square root of 50 falls somewhere, it's bigger than 49 and less than 64, so the square root of 50 is somewhere between the square root of 49 and the square root of 64. So the square root of 50 is somewhere between the square root of 49 and the square root of 64. We need to know the square root of 49 is 7 and the square root of 64 is 8. So that means that the square root of 50 is between 7 and 8. So the next two are asking us to estimate the square root to the nearest tenth. So what if we want to know more than just where the square root falls between, like the square root of 39? Again, the square root of 39 is not on our list of perfect squares. So when we go back up to our list of perfect squares, the square root of 39 is somewhere between the square root of 36, which is 6, and the square root of 49, which is 7. So we know the square root of 39 is between 6 and 7. So we know it's not bigger than 7, so we're not going to use this number because 7 is too big, so I'm going to cross that out when we're looking for the square root to the nearest tenth. So this one, it's too big, because we know that the square root of 39 is going to be 6 point something, and we have to figure out what that decimal is. So when we look at 39, 39 is closer to 36, which is right here, than it is to 49. So we are going to try, and it's not halfway, we're going to try about 6.3. So if we multiply 6.3 times 6.3, we're going to see if we can get a number that is close to 39. So 3 times 3 is 9, 3 times 6 is 18. There's my placeholder. 6 times 3 is 18, carry our 1. 6 times 6 is 36, plus 1 is 37. That's 9. 8 and 8 is 16, carry the 1. That's 9, and we get 39.69, which is close enough. So that means that the square root of 39 is about 6.3. So let's go ahead and try the square root of 90. Again, that's not on our list of perfect squares, but we know that the square root of 90 is between the square root of 81, which is 9, and the square root of 100, which is 10. We're not going to use 100 or 10 because it is too big. So we know that the square root of 90 is going to be about 9 point something, and we have to figure out what that something is. Now 90 is about halfway between 81 and 100. So we are going to try 9.5. So we'll multiply 9.5 times 9.5 to see if we're going to get a number that's close to 90. 5 times 5 is 25. 9 times 5 is 45. Plus 2 is 47. Again, 9 times 5 is 45. Carry my 4. 9 times 9 is 81. Plus 5, or plus 4 is 85. That's my placeholder. So when I add those two together, I get 5, that gives me a 12, that gives me a 0, and that gives me a 9. So I get 90.25, which is very close to 90. So that means that we can use 9.5 as an estimate for our square root of 90. So the square root of 90 is about 9.5. Okay, there's a couple other questions I want to go over, so you can flip your paper over to the back. What happens if we have an expression like this one here, and these you can copy on the back of your paper. We have an expression like the square root of 64 plus 10. How do we solve that? Well, the first thing we want to do, we can't do 64 plus 10 because we don't know what, or square root of 64 plus 10 because we don't know what the square root of 64 is yet. So if we do the square root of 64, that's 8. And if we do 8 plus 10, we get 18. So how is that different from example number 2? What if I have the square root of 64 plus 36? These are both under the same square root sign, so I need to figure out what this is first. In this example, 64 was just under the square root sign, so I had to figure that first, and then I can go ahead and add 10. But because the square root symbol goes all the way over to here, I need to add these two together first. So I'm going to keep my square root symbol, and I'm going to add 64 and 36. And the square root of 64 is 100. I'm sorry, and 64 plus 36 is 100. Now I can do the square root of 100, and the square root of 100 is 10. Okay, try these two examples on your own, then check back. Number 3. 2 squared plus the cube root of 8. In example number 4, the cube root of 125 plus the square root of 25. So go ahead and pause the video and try those two examples. And then check your answers. Play back the video and check your answers. Okay, in this first example, we have to figure out, okay, what is 2 squared? And we know that 2 squared is 4, because 2 times 2 is 4. Then we have to figure out what is the cube root of 8. So what 3 numbers can I multiply together to get 8? And the cube root of 8 is 2, because 2 times 2 times 2 equals 8. Then we can go ahead and add these two together, and our final answer is 6, because 4 plus 2 is 6. In example number 4, we need to figure out what is the cube root of 125. So what 3 numbers can I multiply together to get 125? And that's 5, because 5 times 5 times 5 is 125. And then plus the square root of 25. So what 2 numbers can I multiply together to get 25? And that's 5, because 5 times 5 is 25. Now that I've simplified both parts of that expression, I can just go ahead and add these two together, and 5 plus 5 is 10. So if you have any questions, please sure to ask them in class or come to Smart Block, and have a good night.